I do. John Nylund. Thank you. Again, good evening. Thank you all for coming. My name is John Nylund. I'm Director of Development for Energy, and I'm leading the effort for the company to propose this project. We're here tonight to talk about the Clear River Energy Center. Focus. Not sure. Okay, that a little better. All right, so the Clear River Energy Center is an advanced combined cycle project that utilizes the latest GE technology that they call the H-frame technology. It would make it the most efficient power plant in New England, if not one of the most efficient in the United States. The project consists of 2 trains. Each train has a combustion turbine, a steam turbine, and a generator on a common shaft. The unit is air-cooled. It does not use water for cooling, and it will have dual fuel capability. And what that means is it has the ability to burn natural gas and oil. And the reason for that is that the ISO, likes to have that dual fuel capability for added reliability for when you have a really cold snap and natural gas can become unavailable. Currently, the project's planned commercial operation date for each train is June 1, 2021 for the first unit, and June 1, 2022 for the second unit. The water supply is currently planned to be from a facility that we have in the town of Johnston. It'll be trucked from that location to the site. And what we have done, since we introduced the project, is to modify the water treatment facilities within the plant in order to reduce the demand on water. And what we did there is that we modified the demineralized water treatment system, which is the water comes in and we demineralize it so it can be used in the steam cycle. It's not used for cooling. And then any wastewater that comes from the steam cycle, we recycle that and reuse it. So that made a dramatic improvement, reduction in terms of how much water the facility would be, the demand water for the facility. The site is located in Burrillville, as previously mentioned, and the site itself is actually owned by Spectra Energy. They have a 730-acre parcel. We're proposing to buy 67 acres of that parcel, and within that 730 acres you have a natural gas pipeline, the Algonquin pipeline transmission system, which actually consists of a 30-inch and a 24-inch pipe that comes up from New Jersey and provides natural gas to New England. It also has 2 345 kV transmission lines and a right-of-way that goes through the site. This is a rendering of the project, and what you can see here is this is the air-cooled, this is called an air-cooled condenser. This is the power block building. Within that building is the gas turbine, the steam turbine, and a generator. And this structure here is the heat recovery steam generator, which captures the exhaust heat off of the combustion turbine, used it to generate steam, to send to the steam turbine, and this combination here, this combined cycle, is really the most efficient way to produce electricity using a fossil fuel. The other elements that you see on site here is the administration and control building. These are the water storage tanks. This is a portion of the water treatment building and the maintenance warehouse. This is the oil tank. This is we call it the gas yard. This is the metering station from the gas, which comes from the Burrillville, the Spectra Energy pipeline, which is right over in this location. This is the switch yard where the electricity goes out, and this structure over here is just a stormwater detention pond. The project site is in Burrillville. It's located approximately, the plant itself will be approximately about 2,000 feet off of Walham Lake Road, Route 100. And here you can see the natural gas pipeline and the transmission lines. And this area here is all within the property that's owned by Spectra Energy. We foresee a number of benefits that the project can provide, to not only to Rhode Island but to the region, and those are namely, it'll help meet the region's energy needs. We'll get more into that later. It'll produce reliable, efficient power, and provide an economic benefit that we believe will help assist economic growth within Rhode Island. It will actually reduce air emissions, from power generation plants in the region. And the reason of this I'll get into later, but that's due to the fact that it will be the most efficient plant on the network. The unit, we also believe, will have the ability to integrate, additional renewables to be added to the New England region, and I'll speak more about that. It'll also create jobs, not only temporary construction jobs, but permanent jobs for the operators of the facility, and it'll generate millions of dollars in revenue, from the fact that it's just, being there, but also paying taxes to the town of Burrillville. The need for generation is something that a lot of people have been talking about, but I think it just boils down to basically this, that, the region is roughly about a 30,000 megawatt market, and there are a number of facilities out there that the ISO has identified that have already been announced as closing or have already retired, and they also identified a number of other facilities that are at risk. These facilities are generally older, far less efficient facilities that, when you add all of that up, it comes close to about 10,000 megawatts, which is roughly about a third of the generating capacity in the New England region. In order to meet capacity needs, the ISO conducts what they call a forward capacity auction every year. That auction looks out 3 years into the future. We bid the unit in back in 2016. One of the units was selected in what they call FCA 10. So we're pursuing the development process in order to meet that capacity commitment supply obligation that we have. We believe, putting in a unit like this does help modernize the electric generating infrastructure in the region, and thus, provide some of the benefits I previously mentioned. The renewable support that the project can provide. Renewables, wind and solar, and energy is actually one of the largest renewable energy producers in the United States. So we're very familiar with the characteristics of wind and solar. And one of the attributes that they have is that they're variable and they're intermittent. You can't really call upon them on demand and say, hey, I need power now. So, and the ISO has recognized this, and one of the things I wanted to point out here is that, this is sort of a quote that the ISO had in the 2016 Regional Electricity Outlook document. That's a document that they publish every year. That they noted that, paradoxically, as you add more renewables, you actually create an additional need for having something that will fill in the gap. And the reason for that is that, electric load has to be matched by generation exactly. And that's because the load, the electricity that comes into your lights or whatever, has a frequency, it's at 60 hertz, and it has a voltage, it's at 120 volts. If the load exceeds the generating capability, you'll either see a drop in voltage or a drop in frequency, your lights will dim or whatever, and the system is actually designed to trip were that to occur. So, the ISO has a struggle to constantly, keep the match between generation and load, to be exact, within a couple of hertz, actually. And so, that's what they mean when they say that, adding more renewables creates this additional need. You're changing the market dynamic. Adding renewables, I think, is something that we all want to do, but you have to do it, in recognition of the physics that's going on here of the electric supply system. Supporting renewables, as I talked about, I think the important point on this slide is the reduction in emissions that you can see, with having a unit like this. Currently, we're getting our power from a variety of generating assets that are located throughout New England and actually in parts of New York. And so, if you don't modernize those systems, if you don't replace them with new, more efficient generating, capacity, well, you're just going to be left with what you had before. And so, we have there's well-founded models that you can, mathematical models that you can look at, the region, the whole Eastern Interconnect, everything east of the Ohio River, and look at all the power generating plants and how the load is, causing those plants to operate. And when you plug in a unit as efficient as the Clear River Energy Center, you will see a reduction in emissions in the New York-New England region. Now, 0.89% doesn't really sound like a lot, but that's 0.89% of all of the emissions in the New York-New England region. which this number here roughly equates to about 600,000 tons per year of CO2. So you see, similar reduction of these, other pollutants. But basically, it's probably similar to buying a car that has a better gas mileage, for your transportation needs. The fact that the project is so efficient also has the ability to create additional ratepayer savings. And those savings come from the fact that the project, being so efficient, is able to produce power, use more power using less gas. In other words, it's less expensive, on an energy basis. And, that power is bid into the grid, and, those rates are ultimately passed on to ratepayers. So, we've performed an analysis that's been under review by the Energy Facility Siting Board and by, Public Utilities Commissions and the Office of Energy Resources. They've seen our analyses and, have, currently either, looked at them in this past summer, the year before, and, we'll continue to look at them during the final hearings. The project water supply, as I mentioned earlier, we have modified the plant in order to significantly reduce the water consumption of the facility. It will be, via truck with delivery from a facility that we have in Johnston that's, using these trucks that have the capacity approximately of 8,000 gallons each. The project also has a significant on-site storage capability of water. You're looking at those two tanks that I showed you earlier on the rendering, and that roughly equates to about 2.8 million gallons. About 600,000 or 700,000 gallons of that are actually held in reserve for fire protection needs, leaving you roughly about 2.2 million gallons for which to operate the facility. Our normal water demand, is roughly about 15,000 gallons per day. That equates to 2 trucks. And if you look at the storage capacity of 2.2 million gallons, that means that the unit could probably operate without any truck deliveries for about something a little over 100 days. In summer, the water demand goes up a little bit, just as a function that because it's hotter and the output of the unit varies as a function of temperature. That does have a tendency to drive up the water a little bit. The facility also has what we're calling an evaporative cooler, and all that means is that on the air inlet you can spray some water in there to drop the inlet temperature. That actually improves performance. That's only done periodically on hot days, and we would use tank capacity in order to do that. So we're not anticipating any changes in the number of trucks that we're presenting here. And then in the event that you have an oil-fired event, you have to inject water into the combustion turbine simultaneously with the natural gas, the oil, and that's done in order to help control emissions, the NOx emissions. And so when you do that, you draw down the water storage tanks along with the oil storage tanks, in fairly short order. So the unit has the ability to run in that scenario for about 3 days, after which point in time, you would be needing oil makeup and water makeup in order to continue running. We envision that, that type of a scenario, having to operate on oil, really only occurs in the really cold snap when natural gas is all being used for home heating and what have you. So I'm being told I have a minute left. The contingent supply that we have is a Rhode Island-based water transport company. They have a long-term firm agreement. And then we also had another backup supply with the Narragansett Indian tribe. As I mentioned before, the project is under review by not only Energy Facility Siting Board, but also RIDEM and the Army Corps of Engineers. So there's a significant amount of review that's going on. Obviously, we talked about the job creation and tax revenues already. I think I've mentioned the interconnection with the gas, the electric, the water. Wastewater will be hauled off-site via truck. And here's just a depiction of the electrical interconnection, which is the subject of a separate Energy Facility Siting Board process that we filed jointly with National Grid. And that's it.